Hello class, this is a video tutorial on combining transformations part 1. When identifying transformations in graphs and or in their equations, translations and reflections must be done in specific orders to yield the desired results. This is because not all transformations of translations and reflections are commutative. In case you haven't heard of this term before, a commutative property means action, or in this case the function of addition, is commutative because no matter what order you do it in, you will get the same result. So 3 plus 2 is equal to 2 plus 3. Likewise with Likewise with multiplication, 4 times 5 is equal to 5 times 4. Okay, so here are the results that you need to kind of remember. Any two translations are commutative, and any two reflections are also commutative. But when you start mixing them around, so when you translate and then you reflect, it's not the same as if you take the same reflection and then you do a translation. So it depends on what order you do translations and reflections, and I'll demonstrate to you what I mean here. So here's the function of x squared. So there it is there. Now let's apply the transformation of 2 to the right and then reflect on the y-axis. 2 to the right, we let x equal x minus 2. And then a reflection on the x-axis, we let x equal negative x. Let's do this first. Let's do f of x minus 2 to this function here. That gives us x minus 2 squared. And then if we do this second transformation, f of minus x minus 2. This will give us negative x minus 2 squared. Now I'm going to expand this, or write it in expanded notation, like this. 2 lots of x minus 2, factoring out the minus for both, so minus x plus 2 times negative x plus 2. The two negatives cancel to give us a positive. And then I'm going to combine these again using index laws, x plus 2 squared. So this here is the translation and then the reflection. The end result, let's do this in blue, is the exact same parabola. Oh, let's try that again. There we are. The exact same parabola translated 2 to the right. Whoops. 2 to the right. So 1 and 2. And that there is, just writing it there, f of negative x minus 2. So that's a translation and then reflection. Just to demonstrate now, let's do the exact same transformation, the same reflection, and the same translation, but in different orders. Let's do this one in black. Let's do the reflection first. The reflection is f of minus x. That's just negative x squared. Well, if we were to expand this, that'll just give us negative x times negative x. That's still just x squared. And then the translation, 2 to the right, that's f of minus x minus 2. This gives us x minus 2 squared, like this. Notice how that end result here is not the same as what we have here. So the end result for this is actually almost exactly the same, except it's 2 to the right. So that there is f of minus x minus 2, which if we were to write that in, that's f of 2 minus x. So these two are not the same. So depending on what order we do transformations in, it'll change the end result. As such, it's not a rule for transformation, but it's best to recognize transformations in the following order. Whatever is inside the bracket first. That's usually the horizontal translation or a reflection on the y-axis. So it's mainly this one though. The next step is multiplications. So dilations, as we've seen in the previous video, we can stretch the function. Negations, so reflecting on the y-axis or reflecting on the x-axis. And lastly, just any final addition or subtraction to the entire function itself. So I'll demonstrate to you using these 4 examples here. So let's first recognize what the 2 functions or the 2 transformations are in this one here. Well, in order of what we can see them, inside the bracket first, so that's 1 to the right, and then 4 up. There's 1 to the right and 4 up. Well, let's do the 1 to the right first. That's x minus 1 minus 3. And then we're going to do 4 up. I'm going to expand this, 2x minus 2 minus 3. And then I'm just going to add 4 to go up. This gives us negative 5 plus 4, 2x minus 1. This here is the transformed function of this one. Go ahead, pause the video and give it a go yourself. First, recognize what the 2 transformations are, and then apply them to the function given to you. So here we go. Looking inside the bracket first, that is a reflection on the y-axis. So they reflect on the y-axis. And then 2 down. That one's nice and easy. 2 down. Let's do the reflection first. Sorry, no need for that. It's negative x squared minus 2 times negative x minus 15. Negative x squared is still just x squared. This, however, becomes a positive 2x minus 15. And then we're just going to do the minus 2, which leaves us with x squared plus 2x minus 17. So this is the transformed function of the original here. Let's finish off these two. Let's recognize the 2 functions, that the 2 transformations that you see, always inside the bracket first. So that is 2 to the right, 2 right, and a reflection on the x-axis. So the reflect on the x-axis. Let's do the transformation to the right first. X minus 3 cubed plus x minus 3 squared minus 2 times x minus 3. Let's see if we can't factorize this in any way. X minus 3, all outside of x minus 3 squared minus x minus 3 minus 2. 3. In case you didn't catch what I did, this one has 1, x minus 3. This one has 2. This one has 1. If I take this expression and multiply with this one, I arrive back to this. Likewise, if I take this one and multiply, I arrive back to this one, and so on. Whoops, I just noticed this needs to be a plus. This gives us x minus 3 squared plus x minus 3 minus 2, x take away 5. I'm just going to leave it as it is there because it's just going to go far too long. And then we're going to do the reflection on the x-axis. That's just multiplying everything by negative 1. So just go negative x minus 3, x minus 3 squared plus x minus 5, just to keep it nice and simple there. And so that there is the transformed function of the original here. Here we are. Let's now take a look at the two transformations that you can recognize. Notice first that actually there is a multiplication of x first, because it went from f of x to f of minus x first. So there's actually a reflection on the y-axis first. That's a y-axis reflection. And then it's, here's where it gets trickier as well. Let's say we had f of minus x. How does this become f of 3 minus x? Now remember, whatever you substitute here has to become a positive 3. If we substituted f of x minus 3, notice how the minus and the minus become a positive. If we made it a positive, minus times positive would have been a minus. But we need it to be a positive. So we need it to be x minus 3. X minus 3 is the translation 2 to the right. So these are the two transformations that we've seen here. So applying this first, let's do a reflection on the x on the y-axis first. Negative x plus 1. That gives us e to the negative 2x plus 1. And now a translation to the right, to right, e minus 2, x minus 2 plus 1. Oh, sorry, not 2, 3. Let's change that. This gives us e to the power of negative 2x plus 6 plus 1, which gives us plus 7. So that there is applying combinations of transformations to functions and recognizing the order in which they come in. So hope to see you in the next video. Best of luck.